The Inuit Iron Age is a name that's been used to refer to a small industry which began with the Dorset culture in northwestern Greenland about 700 AD. Known to the Inuit as the Tunit people, the Dorset culture spent several hundred years using iron from a local meteorite fall. They cold worked and annealed it into knives, harpoon points, arrowheads, ulus, and other tools. The metal was so pure it could be hammered, cold worked, and ground without needing to be melted or refined. They didn't need metallurgy because they already had nearly pure metals. And that's the spirit behind this project. I'm going to be making a rotor for a DC electric motor from meteorites and other natural materials, while modifying the meteorites as little as possible. These are the meteorites I'll be using for the construction of the rotor. The Canyon Diablo meteorite from Flagstaff, Arizona, the Sikhote-Alin from Kenya, and the final piece is from the Sikhote-Alin meteorite, which is from a 1947 Russian impact in the Sikhote-Alin Mountains. Buchwald describes the Sikhote-Alin in the Handbook of Iron Meteorites as showing signs of cold working. Fractures and viscous deformation caused by the impact have led to the interesting shrapnel and finger-like shapes, as well as a brittleness in the material. The Canyon Diablo meteorite has a unique shape that was formed as part of a weathering process as the layers of rusted iron exfoliate off of the larger masses. The smaller masses end up sculptured into their own finger-like shapes. And you can see I attached the palisite to the end of the Sikhote-Alin meteorite in order to even out the weight on either side. And to do that, I just threaded the Sikhote-Alin meteorite through a hole in the palisite that was left by the weathering of an olivine crystal that had originally been inside the palisite, leaving behind just the metal skeleton of the palisite. And I attached them together by literally just taking the Sikhote-Alin meteorite and putting it through the Sikhote-Palisite and twisting the edge of the Sikhote-Alin meteorite around to tightly grip onto the Sikhote-Palisite. And here you can see I'm attempting to melt shellac into a hagstone that I'm using to attach the two meteorites together. And failing. There's always the blowtorch. So around the 7th or 8th century CE, the Tunit resettled the eastern high Arctic, including Avanerswak in northern Greenland, a region that had been abandoned for centuries, which I'm sure I also just mutilated. Artifacts made from this iron have been found all across the Arctic, from Smith Sound to Somerset Island and Igloolik. The Tunit traded more than just metal. Their networks moved soapstone, antler, quartz, ivory, and driftwood, and as well as perishable goods like skins and blubber. Fox Basin was a central hub, a long-term Tunit stronghold, and likely a key exporter of ivory. They also traded native copper, mostly sourced from the Coronation Gulf, and though rare, it does show up across the Arctic, with one standout site, Little Cornwallis Island, yielding over 50 pieces. Then, in the late 11th and 12th centuries, the Inuit arrived from Alaska. And here you can see the quartz crystal that I'll be using as the commutator. It's two wires, copper and silver, that I've flattened out and shellacked to the crystal, which I ultimately tied down with raw silk thread and shellacked it. You can see that here. And then I attached it inside of that hole in the hagstone with more thread and shellac. And a little bit of hide glue as well. So in the 11th and 12th centuries, the Inuit arrived from Alaska and outcompeted the Tunit, but inherited their metalworking traditions, entering what archaeologists call an epimetallurgy age. Blade slots and rust stains remaining in the metal's absence suggest that the metal use remained widespread in Avanerswak. And this is my wire wrapping machine that I created some time ago. It's loosely based on a fishing rod wrapping machine that I found online, only this draws the wire through and then wraps a piece of raw silk thread around the wire as it's going through. Now, while the Tunit people and the Inuit people didn't make wire themselves, other native peoples in the Americas did make wire out of copper, gold, and silver without the use of any modern tools like pliers or wire draw plates. They did it using the strip twist method, which involved taking the metal, hammering it completely flat into a thin plate or foil, and then cutting that into strips and twisting those strips upon itself until you had a thin wire-like tube, which you could use in decoration. I'm just cleaning up the wires that are attached to the commutator. I'm going to ultimately wrap the wire that I just insulated around the meteorites here to create the armature. And I need some place to attach the wire to the commutator. My hands have always been shaky. And the wire's now been wrapped in silk thread and dipped in shellac to ensure it's completely insulated. And I'm going to start in the middle and wrap out to the end, and then wrap back across to the other end, and ultimately back to the middle. What this wire wrapping does is create a solenoid, which is an electromagnet. Every live wire creates a magnetic field that wraps around it, and when you coil the wire, those magnetic fields stack upon themselves to form a single directional magnetic force. And when you add the ferromagnetic core in the form of the meteorite, it greatly increases the magnetism. So this is it, the completed armature. I hope you enjoyed the video, and please stay tuned for the completion of this project. Thank you very much.